Good morning, guys. Today we are going with one more problem on heat transfer. Now once again it is a 2D problem. Now difference between previous problem and this problem, while solving a problem I will explain what is the difference. Just go through the problem. A plane wall x k equals to 75 watt per meter Kelvin is 60 mm thick and has a volumetric heat generation of 1.5 into 10 power 6 watt per meter cube. Okay, it is insulated on one side while the other side is in contact with the surface of another wall y, k equals to 150 watt per meter Kelvin, which is 30 mm thick and has no heat generation. Okay, the free surface of wall y is exposed to a cooling fluid at 20 degrees Celsius with a convection coefficient of 950 watt per meter square Kelvin. Find the steady state temperatures at salient points across the composite wall. This is what the problem. If you observe, there we have only one slab. Here we have two walls. One is k value is different. When two walls are there in 2D problem, how to construct this? That is the one thing. Then one surface heat generation is given, other surface heat generation is not given. Okay, apart from that, now if you compare with the previous problem, the convection, see convection temperature. In previous problem we are not seeing this convection concept. Now we are seeing a convection concept here. How to give one convection is given in 2D problems. Okay, because in 2D we are not going to create any element with respect to convection. Directly we can apply. Now how to do this? Okay, that will be explained. Now if you move to the next slide, just I will show this is what the problem we can construct. See, this is the wall. Okay, x and y, Lx, Ly is given, Kx, Ky is given. See, you want to determine temperature at salient points. What is that salient? T1, T2 and T3. But this surface is exposed to a temperature. See, that is a fluid. That fluid having a H value is 950 and temperature is 20 degrees Celsius. Now apart from this side, it has been insulated. What is meant by insulated? Insulated means heat flux will be equal to 0. Heat flux will be equal to 0. Just like your, if you observe your wires, okay, inside we have an metal wire, correct? It has been surrounded by a plastic. See, there is nothing but what? There is no heat transfer, correct? There is no heat transfer because generally when a current flows, your wire will be heated, correct? But we cannot feel it because we can easily touch the wire. We can touch the wire. We can see that there is no heat will be transferred. Like that, it is insulated means completely it is heat flux will be equal to 0. Like T1, T2, T3 want to determine. See how to determine this. First I will show theoretically. This is a theoretical procedure how to determine your this one. First you should calculate Qg. You are going to get a Qg. Then using your Q value concepts, that means you are using your modes of heat transfer, conduction and convection, we are going to calculate the temperatures T1, T2, T3. Now this is how they are calculated. This is the temperatures. Now in FE model, what to do it? So in FE model, using your answers or answers analysis, how to do it? Same thing, construct two areas are given, A1, A2, that is 60 is 1, 30 is 1. It is in mm. We are going to use it in meters because all the values are given in terms of watt per meter Kelvin or watt per meter cube. Because of that, I will convert all the units into meter. Now here 5 millimeter, the height is not given. You can assume the height. That means it is steady state. The temperature throughout the wall is same. Because height you can assume it. Okay, areas. Now how to solve this using your answers? Just I'll go to minimize this. I'll open your answers. Okay, open the answers. Now take first step. See, almost similar to your previous problem. Take first step, go with thermal, give OK. Then go to preprocessor, element type, add error delete, add. Now what is the element you should add? Solid, quad 455. Okay. In options, replace this by plane thickness. Okay, give OK because we have to apply volumetric heat generation. Now close this. Now minimize this. Real constants, add error delete. Now in this one, just define your thickness value. Now thickness is not given, assume 1 meter. Give OK, close. Now minimize this. Go to material properties, material models. Now thermal, conductivity, isotropic. First value, first wall is 75. Give 75, give OK. Now after this material, new model because I want to give one more. OK. Now go to isotropic, give here one more is 150 watt per meter Kelvin. Now over, see. Material, exit. Now you have created two material models, that means K1 and K2. Now after this modeling, go to create what? Areas, because rectangle, areas, rectangle by two corners. Now first rectangle I'll create 0, 0, 0, width is given, that is 0.06, that means 0.60 millimeter, that is we can make it 0.06. Then height is not given, you can assume it 0.005, that is 5 millimeter. Okay, 0.005. Okay. Now we have created a rectangle, but I want to create one more rectangle. Now I will once again use by two corners. If I use by two corners, then my x and y location will not be 0. I want to start from this particular point, correct? This particular point. Now what is this particular point? X will be 0.06, y will be 0 only. Y will be 0 only. From this particular point, what is the width for second area? That is 0.03. Then what is height? Height will be 0.005. Same height you should give it for fourth. See, over. Now see, now areas has been created. Now if areas is graded, this is a separate area, this is a separate area. But what is in a problem is given that one surface is insulated, another surface is in contact with this. But if you observe this, here you cannot see the contact, but it looks like a contact, but we don't have any contact between these two. See, correct? Because of that, I want to create a contact between this. How to contact it? See, we go to operate. We have an option called glue areas. Okay, now click this and pick this. See, on this line it will glue. That means it will stick just like a pasting. Okay, we are going to make a glue on this line. So you can ask me, sir, why you have gone for glue? You can go for add. See, if you go for add, what happen? It will convert two areas into single area. See, we want two areas only because these are different material, these are different material. Then which is the best option? We should make a glue. We can create a contact surface over this. That's why you should use an option called glue. Minimize this. Minimize this. Next, what is the next step? Go for meshing. You want to mesh it. See, if you want to go for meshing, mesh attributes. Okay. Now mesh attributes, first you should set the default attributes. See, yeah, one only because one. Now I am meshing this first area. For that I kept it 1. Now go to next, after this go to mesh size controls, manual size, lines, picked lines. Now pick first line and second line, that is bottom lines. Now only a first area. Okay. Now how many number of elements you want to create it? 60 mm is there. You can create 30, no problem. 30 element divisions I am going to create. 30 element divisions I am going to create. Once again, 2 more lines are there, picked lines. Now this and this I will pick it. Give OK. Now I will create only 2 because I don't, that is not the major important area. Long X direction is major important for that. Give 2. Now after this, see, after this what you want to make it? You want to mesh it. Mesh areas free. Which area you want to mesh it? Only this area you want to mesh it. Give OK. See, now meshing is over, but it is showing only one area. What you want to make it? Once again go to plot areas. Now once again it will plot the 2 areas. It is meshed, but it won't show because I had given, I had only given that plot areas. Now first meshing is over. What is the next meshing you do? Once again go to mesh attributes. Now go to default attributes, mesh attributes, default attributes, replace 1 by 2 because I am going now doing meshing of second one. Replace it, set the default attributes over, then size controls, manual size, lines, picked lines. Now pick the lines of second one. Okay. Now how many number of element divisions? You can give how many you want. I am giving only 18. I am giving 18 or 10. You can, whatever you want, you can give it. Okay, 18 I had given. Okay. Now go to once again picked lines. Okay, because I want to do this too. Correct. Pick this. Give OK. Now here once again give element number divisions 2. So you should maintain same value. What you are given for this line here, or because already we have done it 2. No, you can maintain that only. Now observe. See, after default all this one. Once again you have to go for mesh areas free. Now select this area. Now check it, you can completely get the model. See, complete model has been meshed. See, this area having your default attribute is 1 because k value is 1, that is 75. This area is having your default attribute k will be equal to 150 watt per metric Kelvin. This is how you can mesh 2 different areas with 2 different k values. That means individually you should mesh it. Individually you should mesh it. Over this, next, what is the next step? Go for your applying your loads. Now where you should go? Go for define loads, apply. See, here apply, go to thermal, temperature is not given, it is not required here. See, what is no? Convection is given, convection on lines. Where is you want to apply convection? See, this line is in contact with the fluid, correct? Give OK. Now how to give, what is the film coefficient? See, film coefficient is given 950 watt per meter square Kelvin. See, that is film coefficient. Then what is the bulk temperature? 20 degrees Celsius. Temperature is given. Give OK. Okay. Give OK. Then after this, convection, what do you want to do it? Heat flux. See, it is insulated, correct? Where it is insulated? On lines. Which is the line? Select this line. Give OK. Now what is here? Heat flux 0 because it is insulated. 0. Now I had given heat flux. Then I had given convection. Then what is the next step I want to do? Heat generation. Go to heat generation. On areas. Which area I want to give? This area. Give OK. What is that value? 1.5 E6. 1.5 E6. Give. Okay. Now see, you are given heat generation, you given heat flux, you given a here convection. See, in this surface I am not going to apply anything because he told that it is 0. Sorry, no heat generation is there because if you not applied it will be 0, automatically it will be equal to 0. Leave it this. Now after this, now everything is applied. Go to solve current load step. Now solve the problem, current load step. Now solution is done. Close this and close this. Now go to minimize this. Go to general post processor. Now go to directly plot results, contour plot, nodal solution. Now DOF solution, nodal temperature. Just click nodal temperature. Give OK. Now you obtain temperature here. See how to check this temperature at the salient points because he told that determine temperature at salient points. How to see that? See, what are the salient points as per the problem? See, this is one salient point, correct? that this location. Similarly, contact between two areas, that is a one more salient point, and one more is in contact with a convection. See, three salient points. One is a insulated surface, another one is a contact surface, another one is what? It has been exposed to fluid. That means three salient points. How to check the temperature at three locations? See, we have an option called, go to query results, subgrid solution, temperature, I want to check it. Give OK. Now it will come, a pointer will come. Now check on all the three surfaces. Now click on this surface. 168.737, that means this location is over. Now check one more location. What is that? I want at this location, just check it, 132.737. Okay. Then you want at one more salient point. See, 114.737. So you can ask me, sir, is it answer is correct or not? You want to check it? Just minimize this. Go to your problem. Go to your backslide. Just check it. See, 168.7, 132.7, 114.7. Now if you check with your answers. See, 168.7, 132.7, 114.737. This is how you can check your answers, or you can just compare with your theoretical solution. This is how you can directly see the results from the clicking on the button. Because here clearly we know that this line, and this line are the contact surfaces. Okay, this is how you can check it your solution. Now after this, say in this problem is not given, plot the graph. See, if you want to plot the graph, use your same procedure what we used for previous problem. Path operations, go for define path, by nodes. Now I'll click this and this. Okay, completely. Okay, give OK. Now it has taken some name, you can give it as a PP, no problem. Some name you can give it, no problem. Okay, then after this, go to next, map onto path. You want to map it, what results you want to plot it. Say temperature I want to plot, I will click temperature. Only temperature I will click. If you want apply. Say if you want gradient, click gradient also, no problem. X along X direction. Here you can type it as a gradient. Now it is not required, but just I am showing how to do this also, gradient. See, what he has given in the problem is just salient points you can determine the temperature. I am showing how to plot the graph also. Say plot path item on graph. If you want on graph, go to graph. What is that? Temperature. Just click on temperature. See, this is our temperature distribution. See, this is maximum here. See, similarly you can see the temperatures here. At the corner also you can see the temperature. What is corner temperature? 114.73. So from the graph also you can see the results. Okay, if you want with respect to geometry, same value with respect to geometry, you can check it. See, this is your geometrical graph. Okay. Now if you want for gradient, same thing, go for gradient. Just click on this gradient, give OK. So remove temperature, gradient, graph. This is our gradient. Say on geometry you required, now click gradient, remove this and gradient, give OK. This is how gradient is. Okay, or this you can get it. See, completely you can get it, but generally here what I required, temperature, I'll keep temperature. This is how temperature distribution is there. Got it? This is how you can check your results for this problem. How to solve it in answers. You can draw the graph, as well as if you want to see the results, go to plot results, contour plot, nodal solution. Just click the nodal temperature. This is a figure what you are going to get it. Okay, fetch. Or this is how you can solve it. Thank you.